All right, so we're going to start a new topic, a new section of topics today. We're going to start doing some logic and thinking. I mean, I guess you could say it's like thinking critically and confusing statements and things like that. And you'll see a lot of this in contracts. I actually have a great story about a lease contract that I caught some weird stuff in it because I knew the stuff that was going on that I'm about to teach you, and it saved me a lot of money. I'll tell that story a little bit later. So we're going to start off with statements and quantifiers, two things that we'll define. They're fairly straightforward. Then they get more complicated. So let's go ahead and just jump right in. So for a statement, definitionally, we'll say a simple statement is a statement that contains one idea. So it's just nice and simple. The sky is blue. Fort Collins is in Colorado. Very simple statements. There's just one idea that's captured by those statements. If I have a compound statement, that's me taking two simple statements and sort of combining them. So I might say something like the sky is blue and Fort Collins is in Colorado. And that's just two simple statements. I've combined them with what we'll call a connective. I've used that word and. So you'll see here that and is that first example of a connective. We'll call that conjunction. Or is a second example of a connective. We'll call that disjunction. We've also got an if-then statement. So I might say, if blah, 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 then blah, 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 blah. That's called a conditional. And then if and only if, I might say, blah, 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 if and only if, blah, blah, blah. That's a biconditional. We'll see examples of these, so you can ignore my blahs for now. You'll hear me refer to these as just and, or, if, then, and if and only if. A lot of people refer to these as conjunction, disjunction, conditional, biconditional. These are the formal terms for them. I just don't like using them because no one uses these words in real life. You don't hear people saying, oh, and then he used a conjunction in his statement. People just say he used the word and it just makes a lot more sense. It's a little bit easier to follow. So I don't worry too much about these words. Just know that, your book might mention them. You might hear me say them in passing, so you got to know what they are, but I wouldn't spend too much time focusing on those. Just knowing what these mean and being very related, very intimately related with these connectives is going to be important. So let's look at some examples. I'll do an example for each connective. I lectured every day last week, and you were bored. That's a compound statement. I took two simple statements. One of them is I lectured every day last week. A second simple statement is you were bored. I took those and I combined them with a connective. And then let's do this. I'm going to keep lecturing every day of the week, or you will fail the course. And so that right there is, again, two simple statements. I'm going to keep lecturing every day of the week. That's a simple statement. There's one essence captured there. I'm lecturing every day. You will fail the course. That's the second simple statement. And I can connect those with an or, and you'll notice that this statement as a whole kind of makes sense. If I stopped lecturing every day of the week, if I stopped lecturing, you'd probably fail because you wouldn't know the material. And, unless I guess you taught it to yourself, but even then you might not do as well as having someone else help you with it. Let's keep on going. We'll do an if then. So if blah, 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 right? That's what I said before. If I lecture every day of the week, then blah, 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 blah. Well, then you'll pass the class, hopefully, right? And so that's an example of an if then. And then what we've got here is you will pass the class if and only if I lecture every day of the week. And this is a little confusing to read. People don't really use this if and only if statement in the real world that often. But what this if and only if statement means, it means two things. This is a concise way of me saying two different ideas. You will pass the class only if I lecture every day of the week, and you will pass the class if I lecture every day of the week. Now that sounds very similar, but there's a very subtle difference there, and it's a very important difference. If I say you will pass the class if I lecture every day of the week, that's actually exactly this statement. Let me just flip the order of that. Instead of saying you will pass the class if I lecture every day of the week, I'll say, if I lecture every day of the week, you will pass the class. That's exactly what I wrote right here. The second thing that's said here is, you will pass the class only if I lecture every day of the week. And you'll see that's kind of the flip of what I just said. Let me go to a next slide where I have some more on this, and we'll look at this. Like I've been saying, I've got blah, blah, blah before, I've got blah, blah, blah after, I've got a statement A and a statement B. And if I join them with the conditional, the biconditional, that's if and only if, it's the same thing as saying two statements. If A, then B, and if B, then A. So this statement right here is actually two different statements. Coming back here, the biconditional, there's a reason it's called biconditional, because it's two conditionals. It's the conditional in both directions, if you will. So you will pass the class if and only if I lecture every day of the week. That means two things. If I lecture every day of the week, then you'll pass the class, as well as if you pass the class, I lectured every day of the week. So that means this guy means two different things. All right, that's the biconditional. We'll get more into this later, and we'll actually delve into this exact slide a little bit later in future lectures. Let's go ahead and move on to quantifiers and negations of statements. So we've got the idea of statements, compound statements, and how we can connect them together. We've got if and only ifs, we've got or, we've got ands, we've got if thens. But we need some way to talk about how many of things there are. And this sounds very, very simple. You're like, yeah, you just say how many things there are, right? It actually gets fairly confusing when we try to negate these and do the opposite and things like that. But let's look at these examples. So I've grouped these by sort of type, if you will. So if I use all, each, or every, if I use those phrases, that's talking about everything. All dogs go to heaven. Well, then that's every single dog. That's all of them. I'm telling you how many I'm talking about. I'm talking about all of them, right? You don't have a specific number, but you know that I'm talking about all of them. If I use the phrases no or none, if I say no dogs go to heaven, then you know that I'm talking about 0 dogs. Not a single dog goes to heaven. And that tells you how many I'm talking about. If I use the phrases some, or there exists, or at least one, that doesn't tell you exactly how many there are, but it gives you sort of a range. If I say some dogs go to heaven, or at least one dog goes to heaven, you know that, well, there's at least one, so it's not 0. And that's actually kind of about it. It could be anything more than 0. It could be 1, it could be 2, it could be 3. It could be all of them. We'd probably just write all if we knew that. So some people will say that these phrases here mean everything in between 0 and all. But in theory, you don't really know for sure. Just the idea that I want to get across with this slide is that you've got different groups of phrases that you can use to talk about how many of things that, how many of a certain thing there is. So let's look at negations, okay? We'll come back to quantifiers and talk about those in a little bit. So let's talk about the negation of a statement. And this can get confusing. Let's say I tell you a statement, all dogs go to heaven, okay? And you want to negate that. You have to say something back to me that is always the exact opposite of what I just said. And we'll get into an how to actually answer that question in a second. But I just really want to harp on the fact that negation is a negation is a statement that is the exact opposite, always. So if I tell you a statement, it's my original statement. If that is false, your negation better be true. But if my statement is true, then whatever your negation was has to be false. And this is a great way to check your negations, check your statements. You can always say, okay, if it's true, then mine's got to be false. If it's false, then mine's got to be true. Let's go ahead and look at some examples here. So if I tell you the Broncos will win Sunday, okay? We don't know if that's true or not. We don't know if the Broncos actually won or if they actually lost. But it really doesn't matter, because if I say in reply to that, I give you a negation in reply and I say the Broncos will not win on Sunday. That's the opposite, because if it is true that the Broncos will win on Sunday, then it's definitely false that they won't win. But if it's false that they will win, it's definitely true that they will not win, right? You could use another example that's pretty much the same thing. My car is clean. My car is not clean. It's a very simple negation in this case, because if my car is clean is true, then my car is not clean is a false statement. If my car is clean is a false statement, then my car is not clean is a true statement, right? And so these negations are fairly straightforward, because really you're just kind of adding the word not in front of them. And so, yeah, so there you go. Let's get into a little bit more complicated of an example. So let's say that I give you the statement, all dogs are fuzzy, okay? And I'm going to give us some choices for negations here, okay? So one of these is correct. And let me say something right off the bat. Two of them actually make a lot of sense, but are not the right answers. And that's the first and the last one. If I make the statement, all dogs are fuzzy, and you in reply try to negate that by saying all dogs are not fuzzy, so that's this first statement right here, it's not quite an exact opposite, because and this can be, you hear me pause because this can be a little tough to explain. So I say all dogs are fuzzy. Let's just say that that's a true statement. Every dog that in the world is fuzzy. Well, in order for you to say something that's the exact opposite of that, you don't need every dog to be not fuzzy. You really just only need one, right? I'm telling you that every single dog is fuzzy, right? So if you go and reply and you go, well, all dogs are not fuzzy. I mean, you are saying something that contradicts me, but it's not the exact opposite. Really, the idea that I want to get at here is, if I'm telling you that all dogs are fuzzy, every single dog you ever look at, it's going to be fuzzy. If you just find one dog that is not fuzzy, then you've contradicted me, right? You have negated me. And that actually is this third choice right here. Some dogs are not fuzzy. You only have to find one dog that isn't fuzzy in order to contradict me. Let's contrast that with this guy here. Some dogs are fuzzy. Okay, well, I tell you that all dogs are fuzzy, and you go and reply. You try and say the negation of it. Some dogs are fuzzy. Well, if I'm saying all dogs are fuzzy and that's a true statement, your statement here is actually also true. If you say some dogs are fuzzy, yeah, some of them are. In fact, all of them are, but your statement is not the opposite truth value of mine, right? And you can keep going through the rest of these and sort of convince yourself of why they don't work. You know, no dogs are fuzzy. Well, if I say all dogs are fuzzy and you say no dogs are fuzzy, those aren't perfect opposites of each other. Because if my statement, all dogs are fuzzy, is true, your statement, no dogs are fuzzy, is not necessarily false, because you're claiming that there's not a single dog that's fuzzy. But in order for my statement to be false, like I said, I just need one to not be fuzzy. So that's why it's this third choice here as the sort of negation. Got that listed right here. We talked about that. So if I give you these quantifiers, these statements here, with these quantifiers of all or some do not, or none, right? So I say all dogs are fuzzy, or I say some dogs are fuzzy, or I say some dogs are not fuzzy, or I say no dogs are fuzzy. You can negate that with these corresponding phrases. So then let's go one by one through these. So if I say all dogs are fuzzy, If you say, hey, some dogs aren't, that's the example that we just did. You have found one dog that is not fuzzy, so my statement can't be correct, right? And you've appropriately negated that. Let's do the second example. I say some dogs are fuzzy, right? So there's all these dogs out there in the world, and I go around and I look at them, and some of them are fuzzy, some of them are not. You say, well, hey, no dogs are fuzzy. Your statement is a negation of mine, because if you actually went out and you actually proved to me that there wasn't a single dog that was fuzzy, then my statement, some dogs are fuzzy, is always wrong, right? So these are 1 and 2. Let me do the third and fourth guys up here. So I say some dogs are not fuzzy. If you, in contrast, say, hey, no, all dogs are fuzzy, and I'm like, hey, some aren't, and you go, no, they all are. All dogs are fuzzy. These are exactly opposite of each other all the time, right? If I go out and I find, and I say that I claim that there are some dogs that are not fuzzy. If you go around and you look at every single dog and you find out that they are in fact all fuzzy, then I'm wrong. You have negated my statement. And last, no dogs are fuzzy. Well, I'm claiming no dogs are fuzzy. Do you have to go around and look at every single dog in the world? No. You just have to find at least one dog. And you've perfectly negated my statement, right? Just like in number 3, I said that there were some dogs that were not fuzzy, but you went around and you looked at every single dog and you actually said they all were fuzzy. So I'm wrong. I'm clearly wrong. Looking at number 2, some dogs are fuzzy. So I claim that there are some dogs that are fuzzy. You go around and you look at every single dog and you go, no, they're not. Then I'm wrong. You've negated my statement. Number 1, I say, hey, all dogs are fuzzy, as we've talked about. You just have to find one that isn't, and you've proved me wrong, because I'm claiming that all of them are fuzzy. And you just find one of them that isn't, we're good. You've negated me. Let's do some more examples of negations. So every student taking Math 120 this semester will pass. So I'm claiming that all of you are going to pass. If you want to negate my statement, you want to reply with a statement that is always the opposite of what I've said. Exactly the opposite. If mine's true, yours is false. If mine's false, yours is true. You only need one student to fail in order for my statement to be false, for my statement to not work, right? So if you just say at least one, I could say some as well, but I'll say at least one student will not pass. I'll avoid saying fail. I'll just say will not pass. Then that is a negation of this statement, because you've exactly flipped it. Whenever this top statement is true, the bottom statement is false, and vice versa, right? And so you'll see that here. I've got that written. Now, let's do another example. Some people who are Broncos fans are also Rockies fans. And this one can get a little bit tricky, right? So I'm saying that some Broncos fans are also in fact Rockies fans. Well, if you go out and you look at every Broncos fan and you ask all of them, hey, are you also a Rockies fan? If somebody answers you yes, oh yeah, I'm a fan of both, then my statement is correct, and so you've kind of failed. But if you go ask every single person and you find no one that's a Broncos and a Rockies fan, that's your negation. You found it right there. Nobody who is a Broncos fan is a Rockies fan. You've negated my statement completely. Because if my statement is true, if in fact some people who are Broncos fans are also Rockies fans, your statement is false. You're saying nobody is a fan of both, but I've gone out and I've found people. So your statement is false and mine is true. And they're always opposites of each other. You could do the vice versa as well. Let's keep doing more examples. So there is at least one professor who doesn't have blue eyes. If you're watching this right now, you can't tell, but I have blue eyes. And so there is at least one professor who doesn't have blue eyes. Well, I'm claiming that I have found a professor who does not have blue eyes. So in order for you to prove me wrong, you have to go to every single professor and they better have blue eyes, right? And that gives us our negation. All professors have blue eyes. And let's look at this in sort of the reverse. Obviously, this statement that I'm writing in the sky blue color here, that's ludicrous. Not every professor has blue eyes. But if I say that statement, we know that's false, right? All professors have blue eyes. So the negation of that is that there's at least one professor who doesn't have blue eyes, right? Those two statements, the one that's typed on the slide and the one that I've written here in blue, they always have the exact opposite truth value of each other. If one of them is true, the other one is false. If one of them is false, then the other one is true. If I say that all professors have blue eyes is bogus, that's a bogus statement, then it's definitely true that there is at least one professor who doesn't have blue eyes, right? If I say that all professors have blue eyes is a true statement, I'm like, yep, I verified it, then it is incorrect to say, it is false to say that there's a professor who doesn't have blue eyes, because I've factually found that all professors have blue eyes. And that's where things can get weird, is when I start using statements that clearly aren't true. But you kind of got to step back from, hey, is this statement actually true or not? And just think, okay, if it's true, then what do I do? If it's false, then what do I do? And that should help a little bit. One more example. Here's just the last example written out. One more example here. No nursing student is minoring in criminal justice. Well, if you go out and you find a nursing student and you ask them, you say, hey, are you minoring in criminal justice? And they go, yeah. Well, you're done. You've proven me wrong. You've found a student who is minoring in criminal justice and is also a nursing student. So all you need to do is find at least one nursing student is minoring in criminal justice. And again, these statements are always the opposite of each other. If the first one is true, the second one is guaranteed to be false. If the first one is false, the second one is guaranteed to be true. I've got this here. I realized a typo. It says majoring. Should say minoring. Not a big deal, though. All right. So we've looked at these negations of, quantifiers. Let's pop back to the connectives and then also negation here. And we're going to actually assign symbols to these. So we're going to use these symbols over and over and over and over and over. So ingrain these symbols in your head. Eventually, you're going to start seeing me write these out, and I expect you to just know what they mean. And is this sort of upside down V looking thing, an arrow pointing up, if you will. You'll notice that it's very similar to the intersection symbol, that cap, if you will. Or is this V looking thing? It's very similar in shape to that union symbol, at what we call a cup. And then if then, we put an arrow. And if and only if, we put a double arrow. And so how you'd use these is you'd say A, if A, then B, or you'd say A, if and only if B. For negations, we use this little squiggly line. I'll use that. Some people will use this sort of bracket, this like L looking thing. Most of the time you'll see just that squiggly, but that means negation. So let's go ahead and do some examples. What I'm going to do is I'm going to give you some compound statements, and I'm going to ask you to write out those statements using these symbols. So let the statement A be, it is cloudy, and the statement B is, I will go to the beach. Those are simple statements, each of them independently. And I'm going to connect them in these 4 examples here. I'm going to connect them, and I want to write these out in symbols, okay? So I will not go to the beach. Well, statement B is that I will go to the beach. And what you'll notice is that that's actually the negation, right? Because if I say I will go to the beach, and then you say I will not go to the beach, those are exact opposites of each other, right? And so all we have to write here is negation B. And then the second example, it is cloudy and I will go to the beach. Well, it is cloudy is given by A, and then I use that and conjunction. So that's that up arrow sort of looking thing. I will go to the beach, that's statement B, and we're good. We've got our answer right there. If it is cloudy, then I will not go to the beach. This one is a little bit more confusing. If it is cloudy, so I know that I'm going to be using an arrow here, right? Because that's my if then symbol. So I say if it is cloudy. Well, I'm basically saying if A, then I will not go to the beach. And we saw before, not go to the beach was not B. It's a little squiggly with a B there. So that's what I've got there, right? I will go to the beach if and only if it is not cloudy. I will go to the beach is B. If and only if, I get my double arrow. It is not cloudy. That is the exact opposite of A. That's the negation of A. And so I have B if and only if, not A, right? And here's our four sort of examples right there, where I can take these long English statements and I can just turn them into nice, short, and simple math statements there. They mean the same exact thing. They're just a lot more succinct. Obviously, you got to know the language. You can tell I like my math more than my English. I like these, short, simple, quick, not B, A and B. If A, then not B. B if and only if, not A. I like that a little more than writing out everything full in English. Given that I've just said that, let's actually do an example where I go the opposite way, because you'll be asked to do this. Let's take these statements, and let me be very clear. Each of these 5, these are statements. While they don't look like it, they're very short and succinct. These are compound statements, or in some cases, simple statements. They are still statements, and you can write them out in words. So let's let the statement A be my dog is a golden retriever, and statement B be my dog is fuzzy. So if I look at not A, negation A, then what do I got there? Well, A is that my dog is a golden retriever. So not A is my dog is not a golden retriever. Let me be very clear. If I said something like all dogs are golden retrievers, not A would be some dogs are not golden retrievers, right? That's that negation. You can go back and look at some of those other slides that we talked about to see what I just said there. Again. So now the second guy here, I've got A or B. Remember, we got that V looking thing. That's or. So A or B is my dog. I'm going to be a little succinct here. My dog is golden retriever, or my dog is fuzzy. And there you go. This one here gets a little more complicated. I have not A, and then this if-then arrow and B. So I'm going to do if not A, and that sounds weird. Luckily, we have not A written up here already. If my dog is not a golden retriever, then B. And B is just my dog is fuzzy. And there we go. This is B if and only if A, so this one's a little bit more straightforward. That third one is probably the hardest. My dog is fuzzy. I'm gonna be succinct here. This is not English at all, this is math. IFF stands for if and only if. Be very careful there. Sometimes people will write IFF and people just like look at it and they just read it as if, but they're not the same thing. IFF is math talk for if and only if. I still need to write A. My dog is a GR, a golden retriever. B and A. My dog is fuzzy. That's B. And I'll underline all these connectives and negations. So my dog is fuzzy and my dog is a golden retriever. Boom. We've got that all right there. So that's statements, quantifiers, connectives, negations, all that fun stuff, as well as some statement things here. One thing I do want to mention, as you've seen here on these last two slides, I use A and B, and we'll see later I'll use C, maybe even D. I tend to use A, B, and C. The book and Connect Math even, and actually kind of everyone in the world uses P, Q, and R instead of A, B, and C. But I like to use A, B, and C for two reasons. One, I don't trust my handwriting in being able to write P's, Q's, and R's very well. I actually wrote them fairly well there, but generally I don't trust my handwriting a whole lot. I think A, B, and C look a lot more distinct than P, Q, and R. But also, I've actually had students in the past tell me that they have a very hard time distinguishing between P's and Q's if they have dyslexia or something like that. And so I'm going to use A, B, and C on all my worksheets and everything. Connect Math, we'll use P, Q, and R. Let me be very clear. It doesn't matter. It doesn't matter what letters you use. You could use emojis if you felt like it. You could use whatever you want. So, you know, if you see a problem in the book that you're trying to work through and it's in P's, Q's, and R's, just replace them with A, B's, and C's if you're more comfortable with that. Or vice versa. If you see my problems with A, B, and C and you feel more comfortable with P, Q, and R, change them. It could care less to me. It won't change your answer or anything like that. But you'll see me use A, B, and C. And we'll get into that more on the next lectures where I'm going to be using A, B, and C more than you probably want me to. And I'll leave it at that. That'll be it for this recording.